Welcome to this chapter 14 question. It's going to be a little longer than typical, but stay with me, it's going to be useful. Classified ads in a newspaper offered for sale several used cars of the same make and model. Listed below are the ages of the cars and the advertised prices. We are asked to make a scatter plot for these, and the result is here, but how do we get to that? If we left click on this that says click to copy to table, let's do this on a clipboard so that we can put it in Excel. And if we paste, then we have the results there in Excel, and we want to make a scatter plot. So if we do an insert scatter plot, voila, we have the scatter plot of price versus age of the vehicles, which is similar to the one that's here. Alright. Do you think a linear model is appropriate? And the question you need to answer for that is a linear model is appropriate if the plot appears to be linear. Now, are we convinced that the plot is approximately linear? It seems like it's starting in this general area and ending here, and the general trend is following a line. So I absolutely think that it is linear. Next thing we are asked to do is to find the equation of the regression line, and it's going to be in the format y is equal to b0 plus b1 times x. And if we go to Excel, we can do that. Go to your data tab, we're going to use data analysis, and we are going to scroll down for regression. Click OK. Your y range is the predicted value, which is here highlighted, and if you highlight the label as well, we click on label. The input range is the year, the age of the car. Do that, and then you click OK. And let me open this up so that nothing. And this regression analysis generates a bunch of information, but the important ones you're looking for is highlighted right here. So I'm gonna copy that and paste it on the first page, since that's where I'm gonna actually need it. Alright, so let's go ahead and move this here and paste what we just found using Excel right there. So we can see the interceptors, and they're gonna want us to round this down to whole numbers, I think. So let's go ahead and do that. So the equation for this is going to be that the advertised price seems to be equal to this value plus this coefficient times the age. Alright? So let's move forward with this and see. That's what it means, that B0 and B1 are what we found here. This would be B0 and this would be B1, based on the equation that we have right here. Alright, there you go. So the regression line is y is equal to approximately 12139 minus 842 times x. So what we're saying, the predicted price for the vehicle dependent on the age seems to be related by that equation. So if you plug x as the year, the age of the car, then y becomes the predicted advertised price. We're asked to check the residual to see if the conditions for inference are met. Now there are four conditions: straight enough condition, independence assumption, and equal variance assumption, as well as the nearly normal condition. The straight line condition is met pretty much by the scatter plot. We spoke about that earlier, so we can proceed through that. The independence assumption is checked if you go ahead and look at the trend. If there are lumps or clumps or anything like that with the regression residues. Now let's go ahead and actually calculate the residues, and to do the residues we need to find the expected value, and expected value is based on the forecast. So what we're saying, the expected value is going to be equal to the intercept plus, and I wanna lock that, so I use F4 to lock that B21, so it gives me a $sign B, $21, and I'll show you why I need to lock it if that's unclear. And I'm going to add that to this value, which I'm also going to lock by hitting F4 multiplied by the age. So looking at this equation, this here represents is B0 plus B1 times X. So let's relate that here. B0, which is in this cell, plus B1, which is in this cell, B22 times X, which is here. I'm not going to lock X, because what I want to do is, once I've calculated that, I want to then hold this handle and calculate for everything else. So I locked it because when I moved down, I wanted it to still reference B21 and B22, but I wanted it to change A2 to A3 when I went down here to A4. So I want this part to change, but I do not want these references to change because you're constantly using these two. That's just an aside. So the residue is going to be the difference between the actual value or the expected value and the actual value. And again, it's just a sign change. So that's the residues. And to get back to what we're looking for, again, if we do a plot of the residues, we will see if there are clumps or any trends in it, or if it seems random. So let's go ahead and do a scatter plot of residues versus age, and I do that by highlighting this, then hitting Control and then highlighting this cell, and I'm gonna insert a scatter plot. And what I'm seeing now, the residual values seem to be just random and all over the place. They seem fairly even. There's a greater concentration closer to the 0 line, so that's gonna help us to pretty much run through the next host of questions that are being asked, all of which checks out in terms of the 4 conditions. The straight line, we look at the plot, residual plot here, see that it's a straight line, and then let's see if we can do this so we have both on the screen at the same time. And what we're saying, so for straight line, we can see that that's approximately a straight line. Independence, there is no clumps or trends or pattern, it's just totally random. And again, it seems normally distributed, where there's more closer to the 0 line and then it falls off exponentially, or at least with a bell curve for that. So this requires a little bit of going back and forth with Excel. A couple of things, let me just recap real quick. You go ahead and you got your data here, and then we did the data analysis to generate this sheet, which is a your regression analysis. And a lot of this you can ignore. We want to focus on the highlighted section, which is the coefficient, as well as the coefficients for the intercept and the age per year in years, and how that factor affects the price. So go back through and see if you can wrap your head around it. Remember that these two values that we found here are equivalent, and those are what you plug in to get the approximate equation. So the price is equal to this constant, which is here, which comes out as an intercept, minus this coefficient times x, which is in age, which is in years. So hope this helps. It ran a little long, about 11 minutes, but take your time, watch it a couple times if you need to. Follow the steps, the data analysis steps. I'm hoping you all have data analysis at this point. If you don't have data analysis, there's a quick way to do it in StatsCrunch, which is not the preferred way of doing it. But if you open it in StatsCrunch, it automatically imports the data. If you go to stat regression, and it's a simple linear regression, your x value is going to be the age, y value is going to be the price, and then you hit compute, and it gives you a similar table to what Excel gave you, with the intercept and the slope being right there. So that's two different methods to do it. One is using data analysis, the other one is using StatCrunch. So whichever one you find easier, then absolutely knock yourself out. So that's it. If you have any questions, please feel free to reach out to your tutor and we will be happy to assist. Thank you.